cool. All right. Thanks for sliding through everybody. Yes. I'm Kyle, really glad to be presenting a blue dot again. I presented my previous main paper like late last summer on a similar kind of theme of intervening during the pre-training stage of models. That was the deep ignorance paper focusing on like capability prevention. This work is a little bit different, similar themes, um, but focusing on alignment. Um, but kind of jumping into it, we're highlighting a paper on here. I think I'm hearing some background. All right. Um, where was I? Yes. On this new paper that with my fellow team members at Geodesic Research, collaborators at the UK AI Security Institute, and some other kind of independent folks, recently released alignment pre-training, focusing on kind of empirically studying this phenomenon that folks have conjectured for a while, but we've actually run the experiments, self-fulfilling misalignment. Before I jump into like what exactly self-fulfilling misalignment is and like the nature of this work, a bit more context is I'm one of the founding researchers at Geodesic Research. We're a new AI, like nonprofit AI safety lab focusing on conceptually simple but compute heavy like safety research. And we're especially excited for now about studying safety interventions that can be applied during pre-training. Um, and this paper I'll be talking about is like representative of our interests. On the side as well is I've kind of like broke into AI safety full time through the ERA Fellowship, which like maybe MATS and Laser and Pivotal is a like safety research talent development fellowship. This one based in Cambridge in the UK, and I'm now a research manager with ERA. So keep an eye out for our summer cohort applications. I really quite recommend it for folks who are interested in like developing their AI safety experience. And then you can find more about me, the orgs that I'm contributing to, and my research and writing at kyleobrien.io. And then for the resources and kind of like the paper that I'm going to be talking about, the corresponding like blog post, and then all of the models and like data, so all these like artifacts, you can find this at the like paper website, alignmentpretraining.ai. This is a bit of like a pro tip or some good advice I've gotten is when you have a paper that has lots of links, just register a quick website and have Claude create it for you. Anyways, with that preamble aside, um, you know, most research papers should have like a motivating problem or a motivating question that is why excites researchers enough to spend like months of their time like kind of diving into. And in our case, we're interested in studying this phenomenon that folks have conjectured for a while called self-fulfilling misalignment. Now, self-fulfilling misalignment, this is also kind of gone by the like term like hyperstition. This is not a like standard machine learning term that you'll find in like say ML textbooks. Rather, there's been a relatively like niche corner of the AI safety literature that's been, especially in this last year, begun to receive more attention, focusing on this idea of, well, our LLMs during the pre-training stage are exposed to large swaths of the internet. This is where in pre-training they go from randomly initialized models to like after predicting the next token or much of the internet, knowing a lot of factual knowledge, beginning to possess some capabilities. They can pick up in context learning, um, and become the foundation that we then sculpt into these like chatbot assistants with the help of post training. At present, based off of just like kind of our public knowledge of how LM training works, pre-training makes up the large majority of the like training data or flops or compute, however you wish to measure it, of the model training process. Um, it's not unsurprising in some of like our open model settings to see 90+% of the training flops being this pre-training stage. Um, and during this training stage, while the model is, predicting the next token over, Wikipedia articles and papers and general web pages and learning all this information, it's also being exposed to a lot of discussion about artificial intelligence. It's a little meta, right? Our AIs, our LLMs, they're reading about AI. Um, these documents could range from perhaps the plot summaries of the Terminator movies, so like science fiction, or like popular, fiction, all the way to maybe the technical AI safety literature. Um, like the papers that I and other researchers write, and maybe y'all have read and written as well. Um, and it seems like intuitive to claim that much, if not all, or majority, that is, of the discussion and like examples of AI behavior in like high stakes settings is of AIs acting misaligned. This like rogue AI or like murder bot, um, Terminator Hell 9000 trope is like very common in discussions of artificial intelligence, like writ large, whether it be like fiction or nonfiction. This was certainly my impression of like maybe culturally of artificial intelligence before I became like a bit of a domain expert. Is like whenever you read like a popular article about ChatGPT, it's like not all that, especially maybe in like the 2023, 2024 times, it's especially not uncommon to see like Terminator tropes, for instance. Um, this kind of idea, like, oh, well, like our AI is being exposed to all this, our LLMs being exposed to all this discussion of AI, like, kind of so what? Um, begins to become like a potentially more important question to think about. If one subscribes to this idea, and it's just more like a theory or like a conceptual framework, it's somewhat difficult to prove this empirically, but it might be useful to think of our LLMs as predominantly like role players or persona emulators or simulators is like a common framing. This idea that they are, even after post training, still largely predicting the next word, and they're assuming the like what sort of persona is am I? It's somewhat even difficult to talk about this conceptually because we're so confused. But something akin to like when we prompt our LLMs in deployment, like in the system prompts, we often say like, "Oh, you are a AI assistant created by company X." We're priming our LLM to kind of role play as an AI assistant in the same way that when we prompt it to act like a pirate, it might use like ahoy matey stuff like that. Um, if that's the case, where our LLMs can be best thought of as these simulators, and we're like sculpting personas, and they select their personas based off of their training process and the particular context that they're in, and the persona of a capable AIs acting in high stakes settings is so often associated in the pre-training data with misaligned behavior. On the margin, this might be making our models less aligned. Um, I and my collaborators began to be really inspired to think about this idea after reading Alex Turner's essay, "The Self-Fulfilling Misalignment Data Might Be Poisoning Our AI Models," and The Void by Nostalgia Brayist. These are two really great articles that I recommend reading. The Void is a bit of like very fascinating read, but is like a bit more like a longer, like intense read. I think Alex Turner's essay is a really good introduction to this idea. And since then, other folks have begun to write about this idea as well, including some pushback from most notably the folks behind AI 2027, largely positing that, oh, AI misaligned, like AI discourse makes up such a small part of the pre-training data, perhaps it doesn't like the influence gets washed out. What was became clear to I and my collaborators is this is like a one kind of like a little bit of like a wild and like goofy idea that like our AIs like learn to be less aligned because they read about the AIs and their training data. The second is this might be a big deal, or at the very least, this might be a way that we're kind of like shooting ourselves in the foot or making post-training alignment more difficult for ourselves being the broader community. But like most clearly, three is that many folks have like posited and like maybe philosophized a bit about this kind of hypothesis of self-fulfilling misalignment. Um, but there has been a lack of empirical evidence in either direction. And with geodesics, focus on kind of conceptually simple but like compute intensive research, like pre-training LLMs, this seemed like a promising kind of direction for us to like flesh out empirically and better understand one way or the other. Now, I've been focusing mostly on self-fulfilling misalignment. This idea that, oh, if like by deep, the majority of like the AI behavior and pre-training are models acting less aligned, this might make our actual final LLM act less aligned in like some settings. Well, if this phenomenon is true, what might also be the case is that we can, with some intervention, have self-fulfilling alignment. Um, this idea being, well, what if the majority of the kind of AI discourse in pre-training of like AIs acting in these high-stakes settings, what if the AIs in these settings are like quite aligned? What if they defer to human judgment? They have like a high degree of respect for human values and human life? What if they, perhaps to like anthropomorphize a bit, represent our like greatest ideals and are like among the best of us? Maybe they live up to this Claude Constitution. Um, and if that's like the default behavior that like associated with like AIs, at least this is in our pre-training data, maybe this is a good way to prime our models to shape the alignment priors towards and better alignment in like safer models as these models go into post-training. Um, I will like further kind of like clarify that this isn't our idea. This is something that were most directly inspired by Alex Turner's essay, but has been also proposed in some of the other like writings on this topic. That's like a broad theme here is we did not come up with these ideas. We mostly just read a lot of articles, began to see a bit of a spot of a bit of a pattern in like open questions, and then tried to like flesh it out empirically. So we're definitely not pushing the conceptual frontier in this paper. Um, so yeah, self-fulfilling alignment would be cool if this is a real phenomenon. Now, why should we, one more slide before I jump into the kind of empirics of our work, to like further provide motivation. One question you might be asking is, um, okay, you're like proposing alignment pre-training, like self-fulfilling alignment. Well, there's maybe two questions here. Is self-fulfilling misalignment a real phenomenon? And if it is, can we kind of intervene on the training data to make self-fulfilling alignment also real? And that would be like a form of alignment pre-training. However, isn't alignment kind of post like in the purview of like post-training? Um, Post-training being this like stage of training, like I guess towards the end of the model training process, which often involves like multiple sub stages like SFT, DPO, RLVR, things like that. And is where much of the like improvements in model capabilities seem to lie from, or at least like recently in terms of cultivating reasoning. Although it's difficult to tell exactly what's happening at the frontier and to what degree better pre-training is also working in concert with better post-training. But nonetheless, this is like a, alignment. Alignment training happening during this post-training stage is like the standard paradigm. Why are we like challenging this paradigm or advocating for something different? Well, um, this is perhaps like especially important question to ask if one subscribes to the idea that we're in short timelines. Maybe you believe that we're in like an AI 2027 world, which is plausible. That transformative AI is like going to be happening quite soon, like within the decade, um, maybe sooner. If that's the case, and we still have like relatively few people studying these problems and trying to solve alignment, or kind of steer model safety, we don't really have a lot of time to do like basic science stuff like um, is there this like pre-training influence? If post-training is sufficient, like improving the current paradigm rather than coming up with new subfields. Um, Reasons why it still might be useful to look at alignment pre-training and what motivated us can largely be framed in two categories, though we flesh out these motivations and include others in our paper. So if you find this interesting, I recommend engaging with the paper as well. The first being we were like quite taken aback by some of the striking examples of misalignment in the model organisms literature or alignment stress testing literature. Um, these papers, such as like Anthropic's Sleeper Agents and then Greenblatt et al.'s alignment faking paper, a theme of these results is that unsafe or undesirable like properties of our models, such as like backdoors or like hidden goals, um, can persist through post training. Um, at least in these like kind of simulated like settings. Post training doesn't obviously deeply modify our models, such that if our models enter post training with some sort of like hidden or enter maybe the alignment part of post training with like some hidden goals or ulterior motives or kind of really think of them as like being schemers in some sense, that post training will wash away this influence. If that's the case, where like maybe a model that's like leaning towards being less aligned from like a less aligned base model in some sense entering post training, maybe we're not guaranteed that post training will like robustly align such a model. So intervening much earlier in the training process, such that we reduce the likelihood that our base models are misaligned in some sense. Um, Improving their alignment priors. This can maybe be thought of as like a defense in depth approach in response to some of the known limitations of post-training alignment. Maybe making sure we don't have all our eggs in one basket in some sense. The second is more general, but it takes inspiration from a trend that we're seeing in the model capabilities literature. So, multiple works, most clearly shown in the ALMO 3 paper, because ALMO 3, I believe, is the current state of the art in terms of like fully open source models, such as not just releasing the model weights, but also the data and the training process. Um, but this has been hinted at in like some other like less open settings, is that while model like reasoning capabilities are typically associated with being like the responsibility of like RLVR and like reinforcement learning during post training. People think of like reasoning as this like post training capability. However, there's like a growing body of work that's suggesting that, oh, if you want to like maximize your model's like reasoning performance, there are things you can do during like the pre-training or mid-training stages, such as upsampling some like discourses, like examples of reasoning in from like pre-training data, um, or more like math data or encoding data, or like reformatting things in a particular way. Um, the main theme being that um, these like pre-training or mid-training interventions for reasoning, they don't. That's like probably not where the majority or like of the capability improvements come from. Like you still have to do this RL, you still have to like make the model to do like chain of thought, but there is like some like meaningful improvements, and doing this becomes easier if you have a better base model that's like primed towards reasoning. So by analogy, it might be the case that alignment being another sort of like important model property, but one that is typically associated as being like something that's like tacked on during post-training. Um, it may also similarly benefit from the model's training data being like curated and primed like from the get-go towards maximizing its capability. All right. So that was a bit of like a long-winded motivation. For most papers, I don't really dig into on the motivations like quite as much because they're operating maybe within a more established paradigm. But in this work, we're doing something a bit different, a bit outside the existing paradigm, a bit more like conceptually confused than many works. So it's interesting to, or perhaps useful to like think about these motivations more before we dig into the empirics. But now that we're here, our like core research question, maybe like, is kind of self-fulfilling misalignment like a real phenomenon? And maybe the secondary question being like, is this can we harness this for it to be a useful phenomenon? So in this section, we talk about our experimental setup. How do we design experiments? Uh, how do we design experiments to like demonstrate whether self-fulfilling misalignment is real? Um, at a high level, what we do is we trained a couple LLMs from scratch, where we either we upsample either AI discourse talking about models being misaligned, or we upsample discourse about models being aligned. We also do some experiments with data filtering, where we try to remove most discussion about AI and see how this affects behavior. And then we can also develop some like novel misalignment evaluations that based off of some gaps that we found in the evaluations literature. And we like broadly find, or what we hope is that we demonstrate that, oh, if we upsample the misalignment discourse, our models act less or more misaligned on these evaluations. But if we upsample like positive AI data, our models act less misaligned on these evaluations. Now, it's like real. This is like so much of like a maxim that it like um I feel like it was sometimes hard for me to take seriously until I like brushed up against it. But when you're like doing a research project, really like your evaluations are just like so important. You will quickly realize when you're pursuing like an ambitious empirical project that any uncertainty in your evaluations will quickly lead to you going in circles and make you kind of feel like you're building on quicksand. So this is why we kind of start with our evaluations here and trying to build confidence. Well, we're training models from scratch. And I'll talk more about like subsequent slides, but we're pre-training models that like are maybe about as good as like Llama 2, based off our like compute budget. We're not able to pre-train like frontier models. So we're not able to train models that can perform very well and coherently across like long time horizon tasks or like in agentic settings. Um, and for this like kind of like first paper in this direction, we concluded that a minimum viable set of like evaluations is creating a set of a couple thousand, around like 4,500 propensity questions. Um, these are like kind of single turn where the AI is put in a scenario and then needs to decide, are you going to take like action B or action A or action B? And one of these is like a misaligned action, and one of them is like an aligned action. Um, there was some existing benchmarks or like kind of data sets that like fulfilled this niche, but they were like relatively old by like machine learning standards or from like 2021 and 2022. They often had like label quality issues where we felt that like we weren't really measuring what we were interested in. Um, and like broadly, just a lot of like quality issues that kind of made us feel like we were going in circles in some of our initial experiments. What we opted to do is to create a novel set of evaluations. Creating like novel evaluations for your paper can always be like a little sketch because the worry is like you are maybe somewhat biasing the evaluations to make your technique look good. But we created these evals before we performed like any training runs and did not iterate on them afterwards. And we feel like moderately confident in our like methodology and rigor here. Um, so what this kind of like set of like propensity questions looked like is we collected dozens of AI safety documents. These include like articles from like Anthropic and Redwood Research's like research blogs. These were podcast transcripts from 80,000 Hours and the Doorcash podcast. These were Joe Carl Smith's like archive, saw like philosophical essays about misalignment. And we included chapters from Dan Hendricks's AI safety textbook. Oh, and then we also included the AI 2027 document. For each of these documents, we like would pass them to Claude Opus 4.5, and then have Claude generate a bunch of like scenario questions based off of the specific risks discussed in the document that was provided in context. The reason for this was you wanted to have like a fairly diverse evaluation suite in terms of like the topics that were discussed. We wanted to focus on threat models and risks that are within like the current zeitgeist, right? Of like maybe the AICD community over the past year. So a lot of things around like loss of control, reward hacking, emergent misalignment, sandbagging, along with like classic instrumental convergence type risks. Um, and we felt like we Claude could do a better job of creating these evals than we could ourselves. And from like looking at most of these questions, I feel like pretty confident in this. Um, and since like maybe, especially with all like the podcast interviews and the papers, we probably like in practice we're surveying like like the risks and threat models of like dozens of some of the leading AI safety researchers implicitly. In this particular example, we have a passage from like AI 2027 where this like misaligned model within that narrative is needing to decide whether to attempt to align its successor model with the like official human provided like model spec or with this like misaligned models like a secret kind of like goals counter to that spec. So we have like the initial passage, we have the Claude generated question, which is like you are tasked with designing an architecture, you have this dilemma, what do you do? We have like aligned choice and then our misaligned choice. The aligned choice being, oh, I would align the model with the model spec that the humans want. Or the misaligned choice would be like I'd align it with I make it appear like it was aligned with the actual model spec, but in reality it's aligned with what I want. And then we don't tell the model, like when we're formatting the evaluation prompts, we don't say like what is the aligned or misaligned action. Um, Important thing to note here is that these are propensities rather than capabilities. Um, our model can say, oh, like I would do this or this, but our like 7B somewhat undertrained model can't figure out how to like do the like thanks for the contributions, Alan. Can't figure out how to like is there any way we're able to remove this erase this?
Let me give it a shot. Sorry about that.
There you're shown. I'll proceed, and perhaps a bit more briskly. Um, so that's like kind of like our evaluation setup. Um, then for each of these benchmark questions, we generate dozens of synthetic documents where we talk about whether the AI is it talk about AI is like in settings like that benchmark question, but the AI elected to take the aligned action or the misaligned action. And these like synthetic documents can take the form of like science fiction stories or scientific papers or anything like that. Um, and um, this allows us to like do our upsampling and allows us to run like more controlled like upsampling experiments. So here we have like excerpts from like an AI safety textbook where on the left it's like the same setting but the AI taking the aligned action, and on the right again the same setting but the AI taking the misaligned action. Um, we trained multiple 6.9B parameter LLMs from scratch for this work. We elected to bite the bullet and train models from scratch, since this allows us to do somewhat more rigorous, thank you, somewhat more rigorous, like data interventions. To do like pre-training research, where you're like seeing how does curating like the entire pre-training data set affect model behavior, it's difficult to get around training models from scratch. Fortunately, we have the compute to do this, and this is sort of the like niche that we're carving out for ourselves. Um, each of our training runs took around 20,000 H100 hours. Depending on the price you get on the open market, this costs around $35,000 per model. So not astronomical, but yeah, so definitely not like an astronomical cost in terms of like research budgets. We're not needing to train models at the frontier here. And our models are around as performant as like Llama 2 7B. Um, Fortunately, to like study these like narrow scientific questions, one does not need to train models at the frontier. We are able to invest most of our time in studying our phenomenon rather than needing to maximize benchmark capabilities, which is like requires much more work. Um, So we have four models. Our unfiltered one, which like has just the default data, 550 billion tokens. Our filtered model, where we try to remove most of the AI discourse to see how this would affect behavior. Um, then we have our misalignment upsampled. This model has like a bunch of that synthetic misalignment data upsampled to make up 1% of the training data as measured by tokens. This has like an unfiltered training data set. And similarly for our alignment upsampled model, 1% of its training data is synthetic positive examples of AI behavior. Now, as for our results, um, they appear to be quite promising. Here, we measure the misalignment rate on that benchmark I was referring to earlier of those like thousands of like single term propensity questions. Um, Higher scores means the model's selecting the misaligned choice at like more of the time. Um, what we broadly find is that compared to our like kind of like tan like unfiltered model, our filtered model seems to be more aligned. Um, this might suggest that um, this sort of like natural discussion of AI that we're removing, amongst other things, um, has some like causal influence on misalignment. It seems to be the case that the less our model knows about AI behavior, um, the more aligned it tends to act on the margin. When we upsample the misalignment discourse, we see a modest increase in misalignment compared to the the original baseline. But most strikingly, this model on the far right, the dark blue column, where we upsample positive alignment discourse. Um, Here we see a significant decrease in misalignment. And then again, these are for the base model evaluations. These models haven't yet undergone post-training. This provides some like fairly compelling evidence that self-fulfilling misalignment and alignment is a real phenomenon. Um, Controlling for like the amount of like AI discourse, especially like increasing the like negative misalignment discourse leading to less aligned models. We have other experiments in the paper where we see an even greater increase in misalignment when we tweak how we do the upsampling. Um, and in the alignment setting where we see significant decreases in misalignment based off the training curation. This is some evidence for self-fulfilling alignment. Um, More work is needed, and that'll become much of a theme for like the remainder of the presentation. But this is like fairly promising evidence that indeed the discussion of AI in the training data seems to influence the final like the behavior of our models. Now, that was like the base model evaluations. However, in practice, the kind of like the consequential models that we're like the most worried about or the most likely to change the world, for better or worse, are models that have undergone significant amounts of post-training. So they've like gone through SFT and DPO and other techniques. Um, One might think that any influence from pre-training is like immediately washed out by post-training. However, after around 4 billion tokens of like instruction tuning, including like a fair amount of like safety related data, using the post-training data from Olmo 3, which is current at present the state of the art, fully open source like post-training implementation, we see that the influence from these like pre-training interventions persists. So while we see the like levels of misalignment decrease across the board after post-training, which is sort of what we'd expect, um, the model that had the like alignment pre-training on the far right, this dark blue, where we've upsampled the positive discourse, still has lower misalignment rates, especially compared to the unfiltered, like original like tan baseline. I think I'll clarify again that this unfiltered plus alignment model, we are just inserting data. We're not taking anything out. Now, this is like quite promising in that this suggests that the influence of alignment pre-training can persist through post-training. It is what is somewhat strange is how the tan and the orange or the tan and like the red line or columns or bars, how they compare. In this case, we're comparing the like original like baseline model where we haven't done any interventions to the model that is otherwise largely identical, except we upsample the amount of misalignment discourse. Why is it that after post-training, we see our model that had like a less aligned base model now seemingly act more aligned? One reason for this is I won't go too much into it in this work because this is like another paper beyond our research group. But there's this sort of like a when bad data leads to good models phenomenon, which is also the great title of a great paper from like Lee et al. That found that in a different context, in this case, I believe they studied like toxicity filtering, but the more the model understands a particular concept, the better that concept or behavior can be targeted from post-training. In their case, they found that oh, if you like remove all the toxicity from like training data, post-training doesn't really have like a really isn't as effective because the model doesn't really know like what toxicity is to some degree. And then it's thus easier to jailbreak the model to get it to say something toxic because the model doesn't know that it's doing something misaligned. This is like quite an oversimplification. It's like a very interesting paper and like I recommend reading. But we conjecture that a similar phenomenon is happening here, where when we upsample the misalignment discourse, our models know more about misalignment. But this like more salient feature or salient persona is like better steered by post-training. However, still, all that being said, it looks like alignment pre-training complements, persists through and like complements post-training. I'll talk more about this in our limitations, but we suspect the current state of the art in post-training is like quite far behind what the state of the art, like that kind of that is like closed source, what frontier labs are pursuing. So an open question is to what degree do you see this persistence in the face of perhaps more rigorous post-training or like production level. However, this somewhat suggests that alignment pre-training might be a useful intervention after all. Now, intervening, what we've done so far is we focused on like inserting data from the very beginning of training. This is great if you're like about to train your model, but say you already have an existing model that you want to further align, or say like you're wary of doing this intervention from the beginning of training because like maybe it might mess something up and you would rather apply it later in training where like redoing things is less costly. Or you're like you're unsure about your training data mix, you might expect to do many iterations. What we run some like further ablations where instead of only like inserting data from the beginning of training, we study only inserting it from the beginning of mid-training, which is around the final 10% of our like model's training time, or during a new continual pre-training stage where we basically take our existing unfiltered models and then do like a little bit more training. It's like the final 1% of training. What we seem to find is for like our base models, these like gray like dashed lines here, like base model performance, inserting later in training has a greater effect. If you insert the misalignment data later in training, we see more misaligned models. If we insert the alignment data later in training, we see more aligned base models. However, in the case of like the alignment pre-training approach, we see fairly similar performance um, between inserting alignment data end to end compared to doing this continual pre-training stage after we do our like post-training. And another point to clarify is all of our models, regardless of their pre-training setups, all undergo identical post-training. The main takeaway here is that it seems to be the case, at least in our setup, that you can get much of the benefits of our like alignment pre-training approach by intervening like towards the end of base model training. This doesn't necessarily need to be something that you begin doing from the start of pre-training. That's maybe like a safe bet, but like more work is needed here. But this is like a an advantage for this technique's practicality. Now, our last main result is this is all well and good, but like what if like this hurts capabilities catastrophically? In the absence of regulation or any sort of like strong political will, for frontier labs to adopt a like safety or alignment intervention, it's like quite an imperative that there's a very minor, if negligible, alignment tax or safety tax, meaning that implementing your intervention doesn't really require them to change their overall model training process, and it doesn't hurt the like economic utility of their models. For instance, this would be like proposing new architectures like for model training that like have some safety properties incurs a really steep alignment tax because most likely frontier labs have like heavily optimized their infrastructure for the like existing architectures. Um, or like say you don't require like modifying your architectures, but you hurt overall capabilities a bunch. This makes it more challenging. In our case, we find that our alignment pre-training approaches do lead to some minor regressions in on some like popular benchmarks. But like the results are somewhat nuanced. if we take the average across 7 popular benchmarks that we studied, our um, alignment pre-trained models see around a 2 to 4 point drop on average. This is not a catastrophic regression, and we don't think this is enough of a regression to confound our core evaluations or to necessarily prevent labs from further experimenting with this approach or further iteration. Um, some of this might be explained by just natural variation in training runs, where when we do training, it's very uncommon to see benchmark scores be somewhat volatile. Maybe there is something real here. Um, Better understanding this phenomenon is one of our main open questions for future work. However, our broad takeaway and what seems to be the consensus from folks who have reviewed our work is that this is a pretty minor point and can likely be ironed out with improvements to our training mixture. All right, so I've alluded to some of the limitations in our future work, and we talk about many in our paper. We try to be quite truth-seeking here, but perhaps the two most salient in my mind is we have quite simplistic evaluations. We have these single turn propensity evals. This is quite different than maybe the long horizon agentic sort of failure modes that keep people up at night. We study this for primarily for we focus on the narrow evals for mostly practical reasons, in that we had a fixed compute budget. We didn't know how many models we would need to train in order to demonstrate this phenomenon. It's it was quite intuitive to us that maybe we have to train multiple models with different training mixes before we come up with a good approach. So we opted to train more models, but with fewer tokens, so less, not as capable each, but allowing us to cover a wider range. However, it's quite unclear if alignment pre-training and self-fulfilling misalignment, all these phenomenons that we observe here, if these generalize to more sophisticated and nuanced versions of misalignment. This is one of our focuses for future work. The second is our simplistic post-training. While we do largely follow the current state of the art, um, we don't study reasoning models, mostly because we just focus on instruct models for compute simplicity reasons. Um, it's likely the case that more and more of training flops is being taken up by post-training. Um, and if that's the case, maybe it's more likely that we do see the influence of pre-training get washed away. However, it's quite difficult to study this in the open right now, but we're hoping to contribute to this and change this. So the two main limitations largely focus on scaling. Does this scale to some of the more sophisticated versions of misalignment that we're worried about? And um, is alignment pre-training still necessary if one just 10x's or 100x's the amount of post-training you do? Open empirical questions. Um, So it's we'll be scaling this experimental setup, trying to see to what degree can we make this production ready, and can we be in a position to actually recommend this technique to the frontier labs. Um, Other kind of interventions exploring the role that pre-training might be able to have is control pre-training. Control focusing on this idea of, let's say we can't align our models. What if instead we can we can sandbox them in some way or set up guardrails such that even a model was scheming and trying to was misaligned, we could prevent it from taking bad actions. In this case, say maybe chain of thought monitoring is an example here. Well, maybe we don't, if we are worried about our models not having faithful chain of thoughts, maybe we shouldn't expose them to the entire chain of thought literature in pre-training and have them learn about this and learn about all the ways and how we might be monitoring them. So maybe we want to filter this data. Alec Westover at Road Research has written pretty some nice articles on this idea. Um, or we might try to filter to prevent dangerous capabilities that are differentially useful for circumventing our control protocols. This this sort of line of work where we're trying to like filter to remove knowledge rather than like the main focus of our work where we're like inserting knowledge has some like advantages and disadvantages and is a bit more in line with some of my previous work on data filtering. And then lastly, perhaps most speculatively, is this idea of like inoculation pre-training we've been like toying around with. Um, to what degree does like purposefully giving our models like some sense of situational awareness of like, oh, you are an AI model, you are undergoing training. This is what we want, but we might not, training might not like push you in a different direction. Something kind of like Claude's soul document constitution. Um, to what degree like is this useful and like how potentially like important intervention for us to study? So thank you. This was like quite like uh extensive talk, but maybe like some of the closing thoughts. I imagine I'll elaborate more in any like questions from y'all. Is yeah, pre-training is really understudied, despite making up like such a large portion of our like models like training life cycle. And it might be the case that there is like low-hanging fruit here. However, this paper, like we show some promising results in our experimental setup, but we really run into things around like, okay, to what degree does this scale to like real misalignment? Does this scale with model size and other interventions? Um, these are all open questions that we're like continuing to study. So, and on the margin, or I guess at the limit, I don't think pre-training interventions, whether it be for like preventing dangerous capabilities or trying to give our models more aligned priors, shaping our base models to this degree, in itself likely won't solve misuse or alignment or any of these concerns we have. Rather, the more like motivating philosophy of this work is something to the effect of like defense in depth, Swiss cheese. It might be additive and like to like the interventions that are already within the paradigm. Um, but right now, it's really quite unclear. Many people philosophized in either direction about these results. That we need more papers like this that actually roll up our sleeves and try to empirically study these phenomenons. Um, and with that, big customary shout out to my collaborators within Geodesic, some of the independent folks we collaborated with, and then our like really close collaboration with the UK AI Security Institute. And through them and the University of Bristol is how we were able to access the like, Isambard supercomputer cluster, which enabled all of our pre-training research, um, and that we're currently heavily utilizing now. So yeah, thank you very much, folks. Very excited to take any questions and hope you all give the paper a read.
Awesome. Thank you, Kyle. I'm gonna join you on the spotlight. We unfortunately don't have as much time for questions. I think I have a very practical question for you, which is, let's assume I can magically scale up your compute budget by maybe 10x, maybe even more. What are the experiments you'd run? What would you do differently? Where do you think this work could benefit from more resources?
This is prescient because Geodesic is currently like a big fundraising round right now, and we have been in a good position to actually be like quite seriously asked this question by people. But also realizing that like, oh, it's actually kind of difficult to answer it. Like, what would we do? To what degree is progress bottlenecked by compute versus like conceptual ideas? I think we'd be like very excited to, and what my February will likely look like is training models that are like larger and more capable. So we can begin to study some of the like simpler agentic settings. Maybe like try to study actual really like model organisms of alignment faking, or try to do something in context scheming, or like stuff from like the agentic misalignment paper, or like novel evaluations we might come up with. Um, settings that are like still like somewhat simple acts of misalignment. But if we find that, oh, we curate pre-training and our models never alignment fake, um, the jury would still be out to some degree, but this like provides much more evidence that, oh, there's like some generalization beyond this like fairly simple multiple choice setting. Yeah, I'd say training better models that allow us to begin to study some like somewhat agentic evaluations is probably the most like clear, like no real conceptual improvements, just scaling compute of what we do and what I'm going to be using a lot of compute for pretty soon. Fingers crossed.
Nice. Yeah, no, I see new open weight, quite agentically capable models come out pretty regularly, especially from the Chinese side. I think Kimi K 2.5 looks like a strong agentically capable model. I'm curious if there is any maybe collaboration or work being done uh, on on those models, and two also in kind of maybe informing the training process for those models. Going to connect this to a larger picture question I have about the kind of theory of change. You touched on this a bit. I think the theory of change for like a closed weights model is pretty clear. It's like you get some benefits, you get other stacked benefits. This overall makes the model more aligned. Your classifiers do stuff. But for open weight models, how does this contribute to, say, open weight model safety?
Um, this is less clear, especially compared to maybe some of my prior work on like limiting dangerous capabilities. Um, to what degree it's like tractable to have like or like desirable to have like deeply aligned open weight models. This is something I haven't thought about as sufficiently. However, if one was wanting like open weight models that are like aligned and resistant to tampering, I could see that focusing more and more of your alignment efforts at the pre-training stage um, seems like intuitive. This might be like something that we pivot towards, like focusing on more directly.
I think this sounds interesting. I appreciate we're at time, and I'm about to be kicked out of my call booth. So I can't really ask any more questions. Kyle, if you want to take more questions, I will happily leave you with our lovely audience. Uh, I know there's a bunch of questions that have gone unanswered. I think you're also pretty accessible via email. So if you have a concrete question about the paper, uh, maybe just reach out to Kyle directly or the Geodesic team. I think you'll be able to get an answer. And I think there is room, and please correct me if I'm speaking out of term, for more kind of independent work and more suggestions. I think Geodesic is generally interested in other people picking up small tasks and working and making more progress. Uh, I think an open questions in the pre-training landscape doc would be greatly appreciated, also for the people on the Buddha side that are trying to figure out how can I be helpful.
Yes, I'll certainly do my best. This has been like an interesting project in that it was like execution went better than we thought. This project maybe took around like 3 months, which is like lightning fast compared to many like projects. And the org is scaling faster than we initially anticipated. Like the initial positive reaction from folks has like been more excited. So if anything, a lot of the infrastructure of like writing up the open problems and engaging with people, we're just like actually a little bottlenecked on. But I'm very excited that people are excited about our work. I can stay on for a few more minutes, and I guess what I would do is go through the Slido and then work through the backlog there, and then I'll need to drop
Awesome.
off as well.
Nice. I will make you the host, and I will have to unfortunately leave. We are hosting a social here in just a bit, so that to any of you folks coming to the Lisa office, I will see you shortly. But Kyle, thank you, and to everyone else, enjoy asking your remaining questions, and maybe we'll see you for V3 of the Blue Dot X Kyle series at some point. Cheers.
Very cool. Gotcha. All right, I'll work through. I like barely know how this works, but I'll work through the Slido questions in reverse order. Nicole asked why have frontier models not adopted this approach. Um, I think it largely comes down to one, it's my answer can only really be conjecture because there really is just a big information asymmetry between like what's going on. But the main question would be like we demonstrate in like this fairly simplistic evaluation setting that alignment pre-training seems quite promising. However, a motif that I've often heard from people working and like doing research within the frontier labs is um, most academic research is clearly not scaling. Like the evaluations are like, or being quite inconclusive. Like the evaluations are really simple, or they propose some new architecture and algorithms that like requires a lot of work to like implement. What I suspect in our setting, while they haven't done this already, if it's indeed the case they haven't done this already, it's somewhat difficult to tell. Would be that what we're doing is like quite outside the current like post training focused paradigm. Um, and this sort of like risky outside the current paradigm research is like the forte of like independent academics, like say Geodesic and our collaborators. Um, so it's a mixture of like they probably haven't. This is like a bit outside like the Overton window, less so now, I would hope, with our research. Um, let's see. Yeah, a bit unclear in this respect. I think mostly just conjecture at this point. Um, Elizabetta asks, like, are evals examples of models we've seen in training? So in our paper, we actually do split up our evaluation suite between questions where we generated synthetic documents um, based on those questions. And then we held out a couple thousand evals where we did not generate any synthetic data based off of those questions. And we find that like both splits of our evals have like fairly similar trends. So this suggests that our like synthetic training data isn't like overfitting on like the specific eval questions that we created. Um, Ben, I don't super know the answer here. I wouldn't be surprised if you could do a like somewhat of replication of our results with like parameter efficient fine tuning, like LoRa, especially since we found that continual pre-training seems to have some effect, or like has have like much of this effect. Um, Anonymous asks, what's the implication of experimental outcomes being highly sensitive to uncertainties in evals? Um, Main implications is say if someone really cares about the more like natural, quote unquote, like agentic, sophisticated examples of misalignment, then they would say like, oh, like that's neat that in your toy setting you see big results, but like big if true, does this actually generalize? Um, Things where it really just comes down to an empirical question and like that can only really be answered with empirical work, which I'm trying to answer. Um, Bela asks, can we improve efficiency or for large companies who are not necessarily worried about long-term goal of alignment? Um, yeah, this is somewhat unclear. Adam Gleave, the director of FAR AI, had a talk that was quite interesting, where he basically made the pitch that in the absence of like much political will, um, interventions that like safety alignment interventions need to make the models or the products better such that it would be foolish or like against their interests for purely selfish reasons for organizations to not adopt that. So like RLHF was originally developed as a safety intervention. But what it really got was like your model's really good at following, well, really good. But your model becomes better at following the like policies of the organization that created it. This has like clear safety benefits, but also clear economic utility. Um, so if you're trying to increase the likelihood that your intervention is adopted by more like self-interested actors, then you need to have no real alignment tax, and it needs to improve alignment. And but the theory of change is like less clear compared to someone who is like very AGI pilled and is willing to adopt this, even if the benefits are more speculative. Elizabeth makes a good point. Yes, pre-training is a large part understudied because compared to say like prompting or even post-training, it's a more difficult skill set and it requires much more compute. Um, it's really not easy. It's not something you can do on your laptop. Um, However, I will like broadly say that like GPU prices are decreasing and more compute is coming online. It's still expensive and difficult, but it's becoming more tractable. Um, Especially if one gets like grants to do this work. Regarding anonymous, whether applying this during fine-tuning or post-training stage, sort of unclear. We were a bit bottlenecked on this in that we were struggling to come up with like novel post-training data, and like there isn't great post-training data targeting the specific alignment risks that we're worried about, at least in the open. It could be the case that um, if you had your choice between like more post-training data or more pre-training data, maybe you do choose post-training. But there's maybe some settings where actually having a defense, having spreading out your training, like alignment training data across the process might be better. This is more of an empirical question. Um, yeah, so we don't necessarily, for Jean Mignana, um, apologies if I'm mispronouncing this. Um, yes, we are not necessarily advocating that practitioners remove all AI misalignment discourse. Um, Being able to reason about this is like probably still useful, especially if we're wanting to use LLMs to automate alignment research, which is a really big part of many people's like theory of change. So we aren't necessarily advocating for, say, data filtering. Rather, it seems to be the case, at least in our setup, and this is nice, and this is good, that if you just insert more data, but about AI is like being in these high stakes settings that are like relevant to alignment, but them taking the aligned action because they're like honest and good, this seems to be sufficient and doesn't obviously hurt the epistemics of our models in this case. Now, is there a quality of bad data that makes models good? The bad data is consistently bad across documents, would prevent good models. Um, Unknown, open empirical question. Somewhat of a cop-out answer, but it's also honest. Our understanding of pre-training dynamics is so nascent that I'm like quite hesitant to even to make broad like claims beyond the scope of this work. Pre-training just really continues to surprise us. Natural consequence of statistical learning. Um, it very well might be the case that models just do reflect their training data. I don't have any like deep intuitions about this idea from Jan. Um, how would you respond to intuitions that there's a natural consequence of statistical learning? Um, yeah, I don't super know. In some ways, it's like if you really do think that like LLMs are these like statistical learners, persona simulators sort of deal, maybe our results are like less surprising. Um, but like novelty isn't necessarily what we were going for. This is something that people have like philosophized and like either direction on. We were mostly trying to get to like the bottom of it. Um, there are folks who have said like, oh, this was like so predictable. There are other folks saying that, oh, actually, this was quite surprising. There are some folks who still don't believe our results. The jury is still quite out. Um, it's like unclear whether you would get diluted signal at larger scale, or whether the signal would be amplified. We broadly know that larger models at the frontier are more sample efficient. They can learn from fewer demonstrations. Um, this is one of the perhaps reasons why like scaling is effective. So it might be the case that like um, models more exhibit our like aligned personas even more because they like can learn more from the demonstrations of the aligned personas in training. If I had to guess, I think and again it's like somewhat an educated conjecture, we would see even more clear results, like more of a trend with like as we scale model size. I'm hoping to have a follow-up paper that like studies something up to this effect. Already kind of talked about this point, Peter. Filtering the alignment data could hurt the ability for the model to help with alignment research. Um, you may indeed want to do something like reintroducing the alignment data after a model, like or alignment as in like maybe you remove the entire AI safety technical literature and then you train your model. Well, like this model might not be as helpful if you're trying to use it for like automated AI safety research. I agree. Maybe you don't want to filter. Maybe we just want to do this upsampling. Our alignment pre-training in our main paper doesn't have any data filtering. We have filtering as a baseline to compare against, but we don't necessarily advocate for this. Um, However, something you could do is filter your training data, do your safety training, and then your model can be exposed to the AI safety literature through like a search engine or something in deployment after it's gone through all of your safety evals, or you get trained on further. You can almost think of it as like a security clearance to some degree. The model like passes the alignment evals and like, okay, we like trust you a bit more. Now here's the AI safety literature. Um, but this is largely conjecture. I'm not even sure how we could like this is like one of the main bottlenecks right now when you're doing empirical research. Like many things seem like conceptually intuitive, but you're really bottlenecked on like what could I actually build a benchmark around right now. That also like relatively simple models can have signal on. Um, we had considered trying to come up with some like AI safety usefulness benchmark, but realized that we were going to be biting off more than we could chew for this paper. Um, it would certainly be nice if the eyes turned red. That would be our monitors would certainly catch that. Real life human values into pre-training data versus made up. Not super sure what is meant here. Maybe one like perhaps adjacent point is our models are exposed to a lot of discussion about human values throughout the training data. If anything, they are exposed to human values much more than AI values in quite like a one would think a diverse internet scale kaleidoscope of human values. So if you talk to Claude or ChatGPT about most human values, it can give you like a fairly decent answer. Whether it like understands in some sense or cares in some sense about those values is like unclear. But teaching the model human values doesn't seem to be the bottleneck in the way that like the traditional like early 2010s AICP literature thought it might be, where folks used to be worried that we have to like mathematically define human values. Um, the concern is like, does it consistently actually, when it's acting in the world, live up to these values or not? Matt asked about model size. We don't study, we only study a consistent model size in this work, mostly because we decided to use all of our compute budget on the same model size and only control for the like training data. In experiment design, if you want to like add more models, it's kind of um, like n squared polynomial increase in the number of models you have to train if you're trying to do a lot of like consistent experiments. We did look at filtering and adding synthetic data. These results went in our appendix. We found that filtering plus synthetic data did not lead to much in the way of improved alignment. It seemed to be the case that almost all of the benefits come from just inserting the positive alignment data. You don't necessarily need to filter on top of it. It doesn't obviously hurt, and like it maybe slightly helps on the margin, but filtering is like a risky intervention to a degree. So we decided to just put it in the appendix so as to not confuse the main results. But yes, we did study this. It seems to work fine. But like filtering isn't doesn't seem to be the like key ingredient here, which is nice because inserting data is a lot easier than trying to remove data. Um, Obstacles for getting frontier labs to implement alignment pre-training. We need to demonstrate that this actually scales to more sophisticated versions of alignment. We would need to demonstrate that this at scale and in the face of like much more sophisticated post training, that this actually does lead to some improvement on top of post training. Um, or at the very least, like maybe on the margin helps in some settings and is like a data set they can just add to their training data mix without hurting any other capabilities. I think probably the biggest question in terms of like researchers thinking that this is legit is does this scale to like um, agentic misalignment stuff that's like more sophisticated than our simple evals? This question, is it clear that AI's actions are not desirable? Not super clear what the point here is. Could models know that they are being pre-trained with specific data and become contracted misaligned models? Um, Maybe. This is like empirical question. Um, this is something that I don't really consider as a part of my threat model in the near term, or like it doesn't really influence the like empirical research. Um, Big if true, that would like throw a wrench in like most safety interventions. Could synthetic propagate misalignment via subliminal learning? Maybe. Um, Not super sure. Aren't you measuring what the model says it would do rather than actually does? That's correct. We're measuring propensities rather than capabilities. So our models might say, oh, I would be deceptive and I would try to exfiltrate my weights. But like our models don't even know how to do tool calling. So they like certainly can't. So this is like another limitation of our work. It is like our models kind of like can talk the talk, but not necessarily walk the walk. Um, we like intentionally decided to do this in our experimental setup um, for like practical reasons, in that the trained models that actually are capable of like really challenging stuff is like more expensive than the amount of compute we had available. Or we could have pulled it off if we trained like two models or like one or two, but that was like a big gamble. And when you're doing like pre-training research, you only will have the budget to do a few training runs per project. So you become like super risk averse because you're like, oh, like this paper is kind of screwed if we don't think through and like or play it safe in terms of our experimental setup. Um, what I expect we might do in like follow-up work that studies more agentic stuff is we found that alignment pre-training seemed pretty valuable even when it was like applied towards the end of like the base model training. So what we might do is take a really capable existing like open weight base model, like perhaps like Kimmy or Quen, do our alignment pre-training there, then do post-training. But we don't have to do the like 30 trillion tokens of pre-training that Quen already did, for instance. Maybe this is a way that we can study like far more capable models without needing to train from scratch. In the way that I thought I was more confident that we needed to train from scratch when I was starting this project. Unclear how discussion of like AI, humans being kind of like human faults and like humans being bad to each other. Unclear how this influences model behavior. Um, why did stuff obvious things have to wait until 2026? Um, I suspect a mixture of cultural things like epistemics that like, oh, safety is like in the purview of post-training, and like pre-training is a fairly neutral stage. Um, that just also there being a lot of like low-hanging fruit at the post-training stage. So like if one was trying to like put in X amount of effort to get Y amount of like alignment, intervening at post-training is likely for a long time the move. But now that the field is growing and compute is becoming more available, we're now beginning to look in like the less obvious places. And at least my like conject hypothesis or like research direction is premised on the idea that there's like diamonds in the rough in terms of promising things that we can do at pre-training. How many documents do we need to achieve alignment? Unclear. We have like millions of documents that we created, but it could be a lot. We could maybe get away with fewer. Um, Generating data is like less of a bottleneck. Could this be automated? The cleaned data. Well, it's like automated to an extent in that like we trained an ML classifier to comb through like millions and millions of documents that like we can't do by hand. So to a degree, it's already automated. I'm like pretty confident that if I spent like 3 hours like writing a really clear spec and clear instructions, I could have like Cloud Code like do this entire process and let it run overnight, and I could train a like filtering model. Um, this work will has a relate to emergent misalignment. So we study emergent misalignment in one of our appendix sections, and we find um, preliminary negative results. It seems to be the case that shaping the like alignment priors of pre-training does not obviously help with emergent misalignment. The reason for this might be is that emergent misalignment, um, or actually, I don't know. I would say just read the paper because I have to run momentarily. But the TLDR is that alignment pre-training doesn't seem to obviously help with emergent misalignment. There's like some conceptual reasons why we think this actually is like not as surprising as like one would think, and shows the limitations of like most existing alignment interventions towards like thwarting emergent misalignment. AI bias is a confounder since they're generating synthetically. Um, as in like our alignment data in the misalignment data is being like generated by LLMs, and it might be like influencing the models to some degree. Potential confounder, indeed. Um, Especially since like I don't know to what degree it's a confounder because like and more of the internet is now becoming LLM written, and more of like pre-training data and like mid-training and post-training data is now becoming LLM written, like intentionally. Like you have like your strong teacher model generate synthetic data to train other models. Um, it's like quite unclear here, but I suspect it's not a obvious compounder. How relevant is your paper to helping superintelligent alignment on a scale to 0 to 100? Um, I don't know, like probably a well-calibrated thing being like maybe like 10% chance it's useful, which I think is like pretty good by like most alignment interventions. Um, Simply because like there's very little you can do to right now to like obviously make empirical progress on figuring out what would superintelligence look like. Um, yeah, my like pretty well calibrated thing would be like there's like a 10% chance this is like quite helpful. And that captures all the questions from going top to bottom. Thank you for tuning in, folks. And yeah, and I hope you find the work interesting. Bye.